Hello, my name is Hayden. This is day 11 of doing Leetcode until I get a job. This is Leetcode 1863, sum of all subsets of XOR totals. So basically, this problem is asking us the XOR total of an array is defined as a bitwise XOR of all of its elements, and if we're given an array such as, well, this is much too large, such as 2, 5, 6. We want to find the XOR totals of all possible subarrays inside of it. So the subarrays are 2, 5, 6, 2, 5, 2, 6, 2, 5, 6. And then also the null array, but we won't count that. So we want to be able to find the XOR total of all these subarrays. And if we just quickly check these out, for 2 would be 2, 5 would be 5, 6 would be 6, 2 and 5, what would that be? This would be, let's actually write out these representations just to make it a little bit easier. 5 equals 0, 1, 0, 1, 6 equals 0, 1, 1, 0. All right, 2, 5, what does that equal? Yeah, that's what I thought, 1, 1, 1. So that's actually going to be 7. And then 26 is going to be 0, 1, 0, 0, so that's just 4. And then this would be 1. Then just to check some of my math. Well, we don't actually get the problem. But basically, after we have all these subarrays and the values of these, we just simply will do an addition of all of them. So this can be 2 plus 5 plus 6 plus 7 plus 4 plus 1. And if we go through this, this would be what? 10, 20, 25. So the answer to this problem is 25. So the big idea of this problem is basically how are we going to efficiently create all of these subarrays. And basically, a good idea with subarrays is that you want to start with nothing. So to start, you have nothing. Now, each subarray, all the possible subarrays from like the 0 to the 1th element, so would be simply still this or 2. And then we keep doing this where this stays. The left branch you don't add the next element, and the right branch you do add the next element. So this is going to be 0, 2, 5, 6. So this would still be 2, 2, 5. This would be 2. This would be 2, 6. This would be 2, 5. This would be 2, 5, 6. This is just 6. What would this be? 5. This would be 5. This would be 5, 6. So this is how we calculate all our subarrays. We start with an empty subarray, and then for each we choose whether we don't add the current element or we do add the current element. And once we have all these, we're just going to get the XOR sum of all of them and then add it together. So it's actually a pretty simple algorithm. So let's check out my solution. Basically, I have the create subsets function, which is going to create all of them in a manner similar to what I described. And then we have a iteration over that, we get the XOR result from each of them. which is just XOR res XOR plus the num. Add that to the answer, then return the answer. As you can see, this passes. And then technically a more, this runtime is space, it has a space time complexity of O of n times 2 to the n, and a space complexity of 2 to the n. And by the way, the reason we can have an exponential runtime is because the input can only be 12 units long. So that was a part that made this question a lot easier. And then, technically speaking, we don't have to create all these subsets, and we can reduce our time and space complexity down to O of 2 to the n with a space of O of, what would this be? I believe n. Yeah, O of n. So we can reduce these down to this, and that would just simply be effectively a depth-first search along this tree and storing the results as we go along. So we would go along all the way down this branch and we'd be like, okay, what's the result that we add to the answer? Oh, it's nothing. Okay, and we have the XOR sum at each point. So this is 0, 0, 0, 0. All right, we're adding back 0. We go up, go down, 0, 6. So this is going to be 6. And then you just kind of go through that way. So that would be the more optimal solution. And there also is an O of n solution, but I didn't come up with it, and I don't think I have the right to describe it then. But yeah, this was a very simple little Leetcode 1863.